Well, good evening, ladies and gentlemen. It's another live streaming time. I guess the biggest thing on your minds right now may be the test that you received just before 12 o'clock at noon. I hope you've all received that. I checked with Cal, and he said he had received it, so I guess it did go out. If you've not received it, of course, you need to let me know, and I'll try to get you a copy as best I can somehow. Um, and that brings up a point. I've been changing or adding a lot of emails to my list or email addresses to my list, and hopefully I've got everybody covered now. Uh, if I missed yours, then you probably need to let me know if something is not coming through well. But anyway, I hope that's all cleared up by now. I've added I'd probably say 6 or 7 different emails, and I just went ahead and added them to our list and sent them out like that. Let's talk a minute about the test. Um, One question that came up, and it is for certain that you should put all the answers on a separate sheet of paper than what the questions are. You don't have to rewrite the questions. Just put the number of the question down. And what I would suggest is each of the questions is under various categories. For example, structure of DNA, structure of RNA, replication, translation, and so on like that. And I would put that title under there and then put question one and then the answer, or put the number one in the answer next to it. Um, the big thing is probably going to be to send it to me in such a way that I can read it. And again, I put a note on there that I reserve the right that if I can't read it, obviously I'm going to have to email you back and see if there is something we can do. Uh, Having them upright is a big thing. A lot of folks have been sending things on sideways, and it's going to make it a whole lot easier to grade if you make it upright. Um, if you can space things out, that would be great. Diesel, I would suggest that you type yours to make sure that I am able to read what you've got. And I don't think it'll take you too long, but guys, I strongly urge you, yes, type it, definitely type it. I think that would be a wonderful thing to do. But I strongly urge you not to depend on just your own general knowledge to answer these questions. If you do, your grade's going to be in the 70s at best. You have a chance to use the supplement that I sent you. You have a chance to use your own DNA and RNA review that you did. Um, you have a chance to use your book if you have it. I understand there are some people that don't have their books. And if you have another book that you want to use, I have 2 stipulations. One, that you do not look up answers on the internet. And 2, that you don't ask your friends an answer to something. I strongly urge that you watch the 2 little videos that I have embedded in the supplement. Both of them are very good. They're animated. You may go through and look at them, and you think to yourself, "Now I can't really use any of this." My suggestion is that you take notes of the videos. They're only a total of, both of them together are probably not more than 11 minutes, 12 minutes at the most. I think one is 7 and the other one is 3 something. So I don't know how many seconds there are involved there, but certainly not more than about 11 minutes and some seconds. So I strongly urge you to watch those 2 or 3 times. There are some questions that directly come from that. I remember on 1 or 2 questions on the test, I directly referenced the video and said, you will find the answers to the video. So I strongly urge you to watch those 2 or 3 times. They're going to help you in understanding a little bit more about what's going on. Now, the supplement is very important. It has, I think, pretty much everything the review, DNA and RNA review, it just has additional information. that might help you. There is a table toward the end of the supplemental review that hopefully you can read to find out and there is a little bit of an explanation there, but to find out how to find the amino acid that goes with a particular codon. And again, just remember a lot of the things that you have looked up answers for. Try to remember that. Another thing I strongly urge you to do is when you do this test, that you do it all in one setting. And the reason is this, that if you say, for example, look up an answer on your supplement or have to do the video for 2 or 3 answers in the first section of the test, and then you don't pick it up till 3 or 4 hours later, you've forgotten what you may have seen on the video or what you may have read in the supplement that might help you on other questions. And so if you do it all at one time and set aside a couple of hours, a block of 2 hours maybe, put away all the distractions that folks normally have in this day and time, like your phones where you are texting with someone, or an iPad that you're Snapchat, I guess they call it Snapchat, and do all those things and listen to music. I would strongly suggest, guys, that you put all those things aside and take this test, because again, there's not many tests that we're going to have. We're going to have this one, we're going to have one next week, and we're going to have one the following week. And then pretty much that's going to be it for the college class. Then we're going to have to start talking about a final exam, in which there is going to be a final exam. Now, how we're going to work that, I don't know. That's going to be, of course, probably about I'm just purely picking up a guess here, about 2 weeks, maybe a little more probably than 2 weeks. And then I'm going to have to turn in some grades to Cleveland State. So we're going to have a final exam. Yes, you do have to have a final exam. This is a college class. No matter if we are doing it, a lot of it online like this, that requirement is still there. And so when that is going to take place, as far as an exact date and time, I don't know. And what format we're going to use, again, I simply don't know. We'll have to see how that's going to work out and go from there. Now, I just don't know. I just don't want to speculate at this point. Now, for those of you who are seniors, a lot of decisions are being made now in the next few days, as far as graduation, as far as activities, as far as yearbooks and all those things. Please keep your ears open. Like I say, again, you'll probably know things before I do, but I know we've had faculty have had 2 Zoom meetings this week. The principals are going to meet with the director of schools tomorrow. And we're also going to get some directives from the state as far as what we can do. And so those kind of things are coming up. I think we will have, I know we did a lot of brainstorming this morning in a Zoom meeting. So we'll just have to see how the director of schools and the principals, how they come up, what they come up with. So that will be coming up. Now, I also, just in the last 15 minutes or so, sent you another study review, a biology review for ecology. This one is entitled Biology Review Ecology Biotic. This is basically something you're going to be working on in the next week or so. Your next test again, we're going to kind of follow the same format, but your next test next week will again June 1st ecology review that you got, the one that is abiotic, the one that had all the agencies and everything on the front of it. Again, if you can make copies of these things, that's great. If by chance they begin to let us come into the school and maybe let you pick up things on the school grounds somewhere, I will certainly let you know as quickly as I can. And if they let us do that, then I can make copies of these things and not have to have you have send them to you as emails, if that is the case. Now, I hope it does. I hope that happens that way. I hope it's such that they will actually let me give you a final exam on school grounds, maybe in the alumni center. I'm going to ask if that can be arranged, but of course that'd be a little over 2 weeks ahead, in the future. So we'll have to see what happens. I don't know that we'll be probably not be able to do that. We'll have to see how that works out. Um, so what I'm going to talk about for the next 20, 30 minutes or so is going to have to do with this review that you got, and I understand you only got it about probably 20 minutes ago. So you've probably not got a copy in front of you, but if you have a some paper that you want to take notes, I'm going to be pretty much going down through this. There's not a lot of it that you're going to have to fill in. A lot of it is already filled in for you. There's just a few places that you have to fill in. Probably if you were to type these out on a sheet of paper with the answers, it'd probably cover one sheet and very easily get it all on one sheet. So it's not a lot that you have to do. But every time you do an assignment like this, what I do is I put down 100 quiz grade for you. Now, so far, you've got one test grade, which was the virus graphs that you did. And by far, you've all done an excellent job on those. I've yet to see one that I have not given 100 to. So that's helping you out. Now, this test that you're doing, that's not going to be the kind of thing you just finish it and then I give you a 100. I want to make you aware of that I'm actually going to grade this. If you have a wrong answer, then it's going to be an X and you're going to have points counted off. If you turn it in after 7 o'clock tomorrow evening, then you're going to have points counted off. So understand, this is a test. And again, I want to make sure you understand you should not ask each other questions about this test. Again, Lauren, if it's okay, if I can read it, then that's fine. I don't have to have it typed. Your printing is good enough. Diesel needs to type his probably, but that's just because Diesel's handwriting is atrocious, and everybody knows that. I'm not telling anything that everybody else doesn't know, and he'd agree with me, I'm sure. Mine's no great handwriting, but his needs help. But anyway, writing it out is fine. Just again, as long as I can read it. One thing that sometimes people do is they'll cut off the bottom of the page. Just be sure that you got a good, clear copy, photograph of it, and I can read it. It is fine. That's wonderful. I hope again that everybody got a good copy of the test, and then I hope you're doing well on it. And take your time and look things up, and don't just make snap decisions as to what an answer should be. Make sure the answer is what the answer to the question as it's asked. It's not a hard test, especially from the idea that you can look things up. Okay, probably enough on that. And unless someone has a question, we'll move on to the second part of the ecology. Now, before we actually take the test on Tuesday, our next Zoom is on Tuesday, or not Zoom, but a live stream is on Tuesday. And I'll go over some things on the abiotic, but we'll get to that. Now, some of the things I'm going to talk about today or this evening aren't on the review, so you may again want to take some notes here. I'm going to start out by talking about the 1960s. In 1969, I graduated from high school a long time ago. I know, before your parents were born, I'm sure. But I graduated from high school, and this was right in the middle of a lot of things going on. The Vietnam War was definitely winding down, and I graduated from high school, went to UT C, that's UT in Chattanooga. It's his first year there. I've told several of y'all about experiences there and the very good deal of how much I had to pay to go to college there. But I took biology. Biology one was the first semester, and then they had a semester of biology. And one of the big things that was coming about at that time was the environmental awareness movement. Um, People were very, very, very concerned about the environment. And a lot of things came out of that. Clean Water Act came out of that in the 60s and 70s. Clean Air Act came out of that. EPA, Environmental Protection Agency, came out of that. A lot of things came out of that. Tremendous awareness about the environment. Interestingly enough, there was a book that was actually required reading for my biology class in college. And I don't think I ever read the whole thing. Well, yeah, I guess I did read the whole thing, but I basically just checked it out of the library. And it was by Paul Ehrlich and his wife. They were in the kind of new field of what is called at that time ecology, which again is the study of interrelationships of organisms with their environment. And in this book, which was called Population Bomb, he and his wife put forth a lot of predictions. And the predictions were such things as we would all, by this time, be eating seaweed. All the oil would be gone, and we'd all be driving electric cars if we were driving anything at all. And that many times we'd have to be wearing air masks because the air pollution was so bad that we couldn't breathe the raw air. It had to be processed in some way. And none of these predictions came true. And yet, many of those predictions influenced lawmakers and people to pass laws. And Paul Ehrlich and his wife would probably say, "Hey, we changed everything by the predictions that we made, even though they were grossly wrong." Um, they caused people to panic. And interestingly enough, one of the kind of sidelines to this in 1973, there was a war over in the Middle East, the Israeli conflict there between them and the Arabs, and the oil was basically shut off. And so we had big lines to get into filling stations, and gas was getting more and more and more expensive. And one of the things they observed, and it's also been observed in this virus crisis, is that the air quality got tremendously better in Chattanooga, which was one of the worst air quality cities in the nation by far, being trapped between hills in the valley of Chattanooga, there in the Tennessee Valley, had tremendous bad air pollution. And that's where my high school was, by the way. We went down there every day to school, and it got a lot better. Now, and you've read or probably seen video where it talks about in Florence, Italy, fish are coming back to the canals. That the air quality in many big cities is getting much, much, much better. Again, because people aren't driving so much, and the industry is not working and stuff. And so, the things that Paul Ehrlich and his wife predicted, bottom line is didn't come true. Now, there was another person who was very instrumental in this, and I think she would be given a credit for a lot of the awareness that was generated about the environment is a lady by the name of Rachel Carson. Rachel Carson. And Rachel Carson wrote a book called Silent Spring. Very readable book. And I've mentioned this to you before, but she made not so much predictions, but she made people aware of some of the problems that were occurring in the environment with the DDT, which is an insecticide. And again, I've mentioned these kind of things before. So um, that again was probably one of the things that book and Population Bomb is one of the two things that really influenced a lot of people. Now, it's a very simple statement, a very simple principle here that good plants produce good animals. And so one of the big things that you have to consider about any ecosystem is what the plants are that are growing there. In fact, any ecosystem that you study is, in almost all cases, is going to be named after the dominant plants. For example, if I go into a forest and a forest ranger comes along and says, "This is a spruce fir forest," like would be found up on top of Klingman's Dome. He or she is meaning the dominant plants in that area are spruce trees and fir trees. Now, around here, we would run into forests that would be oak hickory forest or oak maple forest, um, oak beech. Oak is a very common tree, so a lot of them have oak in there. So whatever the dominant tree is, if we're in a grassland area, it'd be a tall grass ecosystem or a short grass ecosystem or a desert ecosystem. All of those would be based primarily upon what plants. And now what plants are growing there are going to be based to a tremendous degree on the temperatures in the area and also on the amount of precipitation. For example, deserts would be in areas that are less than 10 inches. Grasslands would be in areas where the amount of precipitation is probably between 10 and say 20, 25 inches. And forested areas simply require more precipitation than that. So getting into the 30s and 40s and 50s in terms of precipitation. The kind of forest is also dependent upon the temperature. So all those factors that we talked about as abiotic type things, non-living things, are going to have an impact on what plants are there. And what plants are there are going to have an impact on what animals are there. Animals depend upon the plants. Plants are photosynthetic organisms. They are the producers. They produce food. And animals then are going to be eating that too. So the first thing that we're going to have to classify in terms of animals and plants are these ideas of producer. Producer being a green plant that produces its own food, an autotroph. And at the base of any ecosystem is going to be the plants. And so if you look at, just trying to flip through here and see if I had an illustration showing a pyramid. I don't think I do. Maybe I'll try to show that to you next time. But in looking at a pyramid, what's called an ecological pyramid, it looks just like a pyramid, just a shape, just like a pyramid would be. And the bottom here would be the producers. And then the next, what's called trophic level above that, would be the primary consumers. And primary consumers eat plants. Now, the thing that you have to remember, and this is an important thing to write down, the thing you have to remember is that only about 10% of the biomass or energy in a trophic level, in other words, only about 10% of what the producers produce would be available to the primary consumers. And only about 10% of what the primary consumers are, their biomass or the energy inherent in their bodies, is going to be available to the secondary consumers. Okay. And then you run into classifications like herbivores, which you've probably heard that term since you were in elementary school. Herbivores eat plants, so they'd be primary consumers. Carnivores eat animals, so they'd be secondary consumers, tertiary consumers, and so on. And omnivores, of course, could be in any category above the producers, either primary consumers, secondary consumers, tertiary consumers, and so on. And then decomposers. Decomposers decompose all of them. And decomposers, again, are fungi and bacteria. And so when you look at these, you've got to look at that. You got to think of that basic structure of a pyramid like that. That's a basic kind of organization of an ecosystem. Now, you also talk about things like a food chain. Food chains always, again, begin with plants. Then whatever eats plants. Okay. And I'll try to show you some illustrations of things like this later on. But the hardest thing And I actually ran into this when I was doing my research on raccoons and also helping some other friends with their research in graduate school, is simply knowing numbers. How many plants are there in an area, and what particular kinds are they? Now, plants don't move around so much, so you could theoretically go out and count all the plants. Now, that's when you think of forest around here, or think of a field of grass, you're thinking, my goodness, that's impractical. But it probably is not practical to count every one of them. But there are sampling techniques. For example, if I were to ask you to go up Tellico River and count all of the white-tailed deer, or give me an actual count of all the white-tailed deer up Tellico River, you'd look at me and say, you're crazy. You can't do that because they're constantly moving around. How do you know you're going to count one and not count it a second time or a third time? And so you gradually get into what are called relative numbers, where you say there are more deer to this year than there were last year. And this is basically the kind of information that the TWRA passes on to the Tennessee State Legislature, and they make recommendations then about game laws based on this relative data. Now, how do they get things like this? Well, sometimes it's very simple. You simply walk a trail. Let's say we're concerned about white-tailed deer. You walk a trail and you can keep a record of how many piles of deer manure that you come across. And then you write that down. And you then just walk that same trail the next year, and the next year, the next year, the next year, the next year. And the years that you see a lot of piles of deer manure are years that you think in terms of there being a relatively high deer population. Years that you see low amounts of deer manure, piles of deer manure, then you again look at that and say, well, there's a low deer population. And so you have relative figures like that. There are other methods. For example, in the Smokies, they put out cans of sardines, cut a little hole in them so they'll drip the little fluid in them, tie them in a string through a hole in them, and hang them up on a tree. And they come back through and they see how many of them have been taken, chewed all to pieces by bears, and that gives them an idea of how many bears. And they just keep data like this year after year after year. Now, as long as you're systematic in doing that kind of sampling, and you do the same thing year after year after year, your data can build up, pretty reliable numbers. Okay. Now, can you absolutely positively say that there's that many deer, there's that many black bear, there's that many fish in a pond or whatever? No, not without counting every one of them. And that's again, that's difficult to do. But you can get some relative information, relative idea. There's bag counts. For example, you go up a river and they call them creel surveys, and you're looking in the stringer fish that people have, or look inside their creel, the bag that they have. I like a creel, a bag that they have on their shoulder. And they, oh, he's got 4 fish. Oh, he's got 3 fish. Oh, he got 7 fish, and so on like that. And again, that gives you a relative idea of how people are doing. Now, in Tellico, it's quite different, because Tellico is a put and take stream. They put it in, and fishermen take it out, and they're not terribly concerned about building the population of fish up because they know a lot of them are going to be caught out during the summer. Now, do fishermen going to catch every one of them? Probably not. I mean, there's going to be some that are more intelligent. I always tell some of the boys that go fishing with, say, hey, I catch the ones that are not so smart, and that may be, but the smart ones are the ones that are going to be left behind. But that's going to be dependent a lot again on the plants in the river, believe it or not, and the small fish that the trout eat, and then those kind of things are they're kind of functions of the habitat that the animal's in. So if you improve the habitat, you're going to improve the population of the animal. There's an old adage in wildlife biology that if you have a good habitat for an animal, and the animal has access to that area, then they will be there. Okay. Now that's not always going to be the case. Back in the 1940s and 1950s, people were starving, and so especially in parts of Tennessee where people hunted and that was their culture and that was their life, they practically eliminated the white-tailed deer. And it was the state in response to this would actually bring deer from West Tennessee into East Tennessee and put in various counties there so as to increase the population. Now that kind of thing is done. Game laws can also help animal populations as well by having limits as to what you can take from the population. Those kind of things can help. By and large, though, in terms of white-tailed deer, hunters, people who hunt, are really not that efficient, and they are going to be inefficient at keeping the population in check. And you end up with, in some places, if there is very good habitat, they're overrun with deer. And that's again a function of the habitat and a function of lack of predation. And the interesting thing is there is a place up in north central Tennessee I just read about here not too long ago where they get very, very large deer. And I dare say if you looked at soil conditions in that area, that you'd have some very, very good soil. Good soil grows good plants, or good plants grow in good soil, and good plants will produce good animals. Now, once you do have an idea of what is there, then the idea is to try to figure out how to monitor it and how to get a handle on what makes a population of deer or whatever animal you're talking about go up and down. Now, two basic things is natality, referring to natal, and mortality, referring to the mortal condition. Natality refers to birth, mortality refers to death. Now, obviously, if you have more births than you do deaths, generally a population is going to be increasing. Now, also another factor is immigration and immigration. Now, immigration, I emphasize it starts with an E, is where individuals are going to be leaving the population. Immigration with an I at the beginning is where individuals are going to be coming into the population. Now, the reason or the way I can keep that kind of straight in my mind is E is also the first letter of the word exit. So immigration is referring to individuals that are exiting the population. I is the first letter of the word into, individuals coming into a population. Now, in the United States, for example, our birth rate is less than, and we measure this in terms of children per family. And so if there are 2 children per family, a population with nothing else considered is going to be pretty much steady or constant. If it's less than 2 children per family, population is generally considered to be decreasing. So in the United States, our number of children per family is less than 2. But we have such robust immigration, individuals coming into the United States, that our population is still growing. Okay. Now, if I look at Japan, on the other hand, their number of children per family is less than ours. And it's almost a non-sustainable situation there because Japan hates immigration. They don't like for people to come in. They've been that way for several centuries, many centuries, in fact. They used to be called the Hidden Kingdom, and they are the Forbidden Kingdom. And so they are not real conducive to letting folks come in. So their population is literally decreasing. Now, this is a problem to them because they have many factories. They're a very, very high manufacturing type company or country, and so many of the companies simply can't get workers, and so they are literally doing everything they can, even to the point of paying people to have children, that they can to try to increase their population. So it's kind of an interesting thing there that you think, well, everybody wants to reduce their population. In Japan, it's just the opposite. Now, China ran across this situation back in the 60s and 70s and 80s, and they made the decision to try to drastically reduce their population. So they had the One Child Act. Each family could only have one child. Now, because of the culture in China, boys are highly regarded, and sorry, ladies, girls are not. And so when a family had a girl, in the certainly in the 60s and 70s, in rural areas, sometimes they'd take them out to a hillside and let the girl just simply cry herself to death, or they would have an abortion if they found out the child was a girl. So what has happened now is that because they favored the birth of boys so much, that in China you have a generation of young men who don't have the opportunity to find a wife for every one of them. This is a distinct problem they ran into. So they've actually relaxed and in some cases repealed the One Child Act and are allowing families to have more than one child per family. There's still the cultural stigma of having girls. They want to have boys, and so abortions are oftentimes used in China to determine the sex of the child. Um, so you have it's a complicated situation in terms of countries. Generally speaking, developed countries will tend to have lower population growth than undeveloped countries. That's kind of a generality. Germany's in kind of the same position we are. They've had a lot of immigration, but their birth rate is again pretty low. So they again have about the same situation we are. Now, when you look at populations, oftentimes, and this is something I think I can show you. At least I'm going to try this here. Um, you can see this figure, and I know that that may not be real clear to you, but anyway, that kind of curve, and it's kind of backwards, I guess, from looking at it from your angle. But that kind of curve is called an S curve, and it's a very common population curve in especially animal population, but also in plant populations as well. But really a big thing in terms of animal populations. And so the population starts out slowly rising, and then it steepens, and that steep point is called the exponential part of the curve, or in some cases called the geometric part of the curve, and that's where the growth rate is fastest. And then it levels off and forms what is called a carrying capacity at the top. And I'll try to show you some more of this later on, and you'll have this in front of you next week, and so that'll help out quite a bit. That depends upon several factors. There are several things that control populations, and interestingly enough, when we look at human populations, we're kind of not extremely steep, but our human population definitely has not leveled out. Let's put it that way. And so there are things that will control our population. Interestingly enough, disease is one of those things. And disease is what is called a population dependent factor, meaning that disease is worse where you have the most people. And we see a classic case of this now, that when you look at New York City, for example, and New Jersey, which have the highest deaths from the virus that has the virus plague, that in places in the nation. Now, there may be more reasons than just populations there, and I'm not going to try to get into all of those. A lot of that may have to do with sociology and the way the people travel and stuff, like all kinds of things there. But there's no question that disease can limit a population. In Cades Cove, for example, the white-tailed deer aren't hunted, and so therefore the primary thing that controls the population there is going to be disease. And so periodically a disease will come through the deer population in Cades Cove, and they'll be decimated. People will come in there and say, wait a minute, I used to see 20 and 30 and 40 deer out in this field. Now I see 2 or 3 or 4. And that's the year that disease comes through. And a lot of them have been what's called hemorrhagic diseases, which are terrible disease. You basically bleed out from the inside. A terrible disease. And that disease runs its course and um, is gone. The ones that are left have immunity, and then the disease epidemic came through. It basically ran its course, and more people developed immunity, and we may be seeing that same kind of thing. There's a couple of studies out of California. There's another study out of New York. And these 3 studies have shown that the number of people that are actually or have been infected with the COVID-19 virus is an order of magnitude of probably 10 or 20 times more than what we think today, than what we have tested, than what we have determined by testing. And that these people may have immunity to the virus now. And so I dare say that if we ran across 200 people in traveling in Knoxville or Chattanooga or someplace like that, I dare say quite a few of them, according to these kind of studies, maybe of 100 people, probably 20 or 30 of them have already had the virus and don't show any effects of it. Didn't even know they had it. And so that builds what is called a herd immunity. And that may be what we're seeing now, where the curves in states are beginning to flatten out a little bit. And that, again, is why governors are oftentimes looking to say, hey, we want to get our people back to work. And again, using the social distancing, which is common sense about this time, and just good cleanliness, and not coming to work when you're sick. All kinds of little rules like that will help them to maintain the good conditions here. Okay, we're gonna wind up here, and again, don't forget the test. Keep working on it and look things up. Don't just put down the first thing that comes to your mind. You may have to read something 3 or 4 times and make sure you get everything in it. I hope you do well on the test. Remember, the deadline is 7 o'clock tomorrow evening. 7 o'clock tomorrow evening. And so please, and by the way, remember, when you turn things in, there's a timestamp on them. So be sure you turn those things in. If you haven't turned in the other things, certainly do that. If there's anything I can help you with, y'all been communicating pretty well with me in terms of emails. And Caden, what do chromosomes make? Chromosomes are made of DNA and protein. Therefore, they make the DNA in them makes what DNA makes. And so there, if you know that chromosomes have DNA in them, then you know what they make. Okay. And so you got to remember, chromosomes have DNA in them, DNA and proteins. And so what DNA can make, chromosomes make. I hope that helps. Did anybody have questions? I'll be glad. Sometimes I may not answer, but hopefully I can help you some. All right, we'll see you later. Oh, okay. Thank you. We appreciate that. We'll see you. Bye.